All right, so before we get started, it's important to remember that air leakage is a real problem in the places we live. It causes discomfort, moisture, and humidity issues both on the too humid and the too dry side. It diminishes air quality, and finally, it wastes ours and our clients' utility bill dollars, thus increasing carbon emissions at the exact same time. So reducing air leakage in our new and existing housing stock is very important. If you're trying to meet the legal building code or achieve a low energy rating, an energy certification, or a green building certification, the reality is that air leakage is part of that. And reducing that air leakage is as much of an art as it is a science. Now, when you have to hit that air leakage goal through a code or one of these programs to get your funding, how can you know for sure any time that you're going to meet it? Now the thing is we no longer have to guess. We actually can know. And so with that, I'm excited to welcome you to our discussion on envelope sealing with automated blower door and directed technology. Now, before we get started, we always do our membership spotlight shout out. So everyone, please join me in welcoming Julie Roth of the City of Ann Arbor, who's been elected to our board of directors, class of 2024 through 26. And she's also recently renewed her certified green home professional designation. You too can join us in achieving your certified green home professional designation on September 30th, both live and in person at no cost if you become a member when you register for this course. There'll also be options for virtual on demand preceding that to take the class at that capacity. Now, support for Green Home Institute also comes from Panasonic Ventilation. Once you air seal, as we're going to talk about today, your project, you now need to ensure proper ventilation. And Panasonic Ventilation offers all the solutions for healthier home needs, from supply only all the way up to demand-controlled energy recovery ventilation and everything that's in between. I've been using Panasonic personally where I've lived for over a decade to keep air fresh and healthy. Energy Star certified inline fans and or exhaust fans to meet baseline ventilation requirements, or set up to continuous or intermittent exhaust to comply with various standards. Energy recovery ventilators ranging from 20 to 200 CFM, decentral or central systems that work in cold climates to help the best balanced solutions. These are paired with demand-controlled air quality sensors so they ramp up to run when pollution is detected. Head over to greenhomeinstitute.org/Panasonic Ventilation to learn more. This session is brought to you by the Green Home Institute. The Green Home Institute is a nonprofit with a mission to empower people to make healthier and more sustainable choices in the renovation and construction of the places we live. Today, I will be your moderator. I'm the education manager here, and my name is Brett Little. As always, these courses are approved for multiple continuing education units, including 3 out of the 5 green pillars in health, energy, and materials in our certified green home professional. AIA Health, Welfare, and Safety may make it applicable to your state-based design or contractor license. Check out the Passive House 5-digit code at the end. You will receive that if you attend for the entire CU hour. So with that, I am super excited to now hand it off to our speakers here today, Bill Shadid, Ross McPherson, and Shane Schubert, who will be joining us with AeroSeal, and Ross with his construction company, who he'll introduce as well. So Bill, Ross, Shane, welcome, and please take it away.
Well, thanks, Brett. Hi, everybody. I'm Bill Shadid. As Brett mentioned, I'm going to kind of lead our discussion today, but we're going to have a lot of contributions from both Ross and Shane as well. Real quick, I'm going to share my screen and get our slides up on the screen. So you should see those on the screen now. I'm going to go into presentation mode. To be able to see a slide that's basically our title slide for today. We're going to be covering, as Brett mentioned, envelope sealing with an automated blower door directed technology. The agenda that we're going to cover today is real quick. We'll review this agenda. We'll do some brief introductions so you know a little bit about the background of each of the speakers. We're going to cover the topic of why seal the building envelope. Talk a little bit, briefly about manual envelope sealing. Then we'll really get into an in-depth overview and discussion on this technology, which is a blower door directed automated envelope sealing. And then what we've also got today, which I think will be really a lot of fun, is we'll share a number of lessons from real job sites where this technology has been used. And we should have plenty of time at the end for Q&A as well. So with that, I'm going to go ahead and get us started with speaker introductions. Ross, if you'd like to go first, followed by Shane, and then I'll finish up with the introductions.
Thanks, Bill. Good afternoon to most of you, and good morning or evening to the rest of you. My name's Ross McPherson. I am an application engineer here at AeroSeal. My background, I stopped building a little bit more than a decade ago. I struggled to find a good rating partner, and I figured if I was struggling to find a good rating partner, then other builders in my area were as well. So I became a rater and a consultant, and did that for a number of years with both HERS Ratings, LEED, and a few others, and then became an aero barrier installer back in 2019. Did that, ran that here in Massachusetts for 3 years. And then I moved over to not quite the dark side, maybe the gray side here on the corporate team. And my job is to help translate the value of what we do to architects, builders, homeowners, code officials, and try to do some value engineering to highlight the benefits of a tighter envelope in construction projects from custom all the way up to production. So Shane, you want to give an intro of yourself?
Hey everybody, my name is Shane Schubert. I'm an owner of a dealer here in the Nashville, Tennessee area, and we've been doing it for 4 years now. And we work primarily with new construction, but we also have our hand a lot in remodels and stuff like that. So it's a phenomenal technologies, and just excited to talk to you guys about it.
Great. Thanks, Shane. Again, my name is Bill Shadid. I work in strategic marketing at AeroSeal. And my background is real quick. I've got close to 30 years experience now in the building design and construction industry. I started my life as a green and sustainable architect a long, long time ago. We didn't use those words. We used words back then like energy conscious design. But this has been a passion area for me for quite some time. Over 20 years ago, I changed over and got into the product side of the building design and construction industry. And I've worked with a number of newer sustainable building technologies such as this one. Been here at this company now a few years, and excited to share a lot of good information with you today and answer, I know what will be a lot of really good questions. So with that, I'm going to go ahead and get us moving forward. So let's start with why seal the building envelope. Really, this visual is just meant to say, hey, look, what are we talking about today? What are we really trying to do? If you look at the visual on the left, the illustration on the left, you can see a lot of air leaks right around the exterior shell of that house. And really what we're trying to do is create an air barrier represented by that continuous red line, which many of you will probably recognize from construction documents where you may use that similar type of symbol or graphic terminology to indicate where the air barrier is. So that's really what we're trying to do, is get as good of an air barrier between the inside of the home or the building and the outside environment, so that we can better control that interior to be better, more comfortable, more energy efficient, healthier, and safer. Ross, you want to go ahead and take over now and just go ahead and just kind of take us through a few more elements of why we do air sealing?
Yeah. So we've talked a little bit about some of the reasons why, but a lot of our customers are trying to achieve a standard, whether it's a code standard or a high performance standard, something like FIAS, Net Zero Ready. So a lot of those are actually big drivers in setting air tightness goals in different regions of the country. When we think about those programs, some have very specific requirements. Energy Star is revising their radar field checklist, and that should be coming out in November and December. One of the things they are adding to that in the air sealing details, as well as cleaning up some of the language, is an ACH backstop. And right now that looks to be right about 4 ACH regardless of climate zone to participate in Energy Star 3.2. So we'll wait for the full release when they have that after they finish taking the last of their comments, but we are expecting that. So we're glad that the codes are recognizing and these programs are recognizing the importance of envelope tightness. We can go to the next one there. When we think about, I think we skipped one too many.
Nope.
Did we lose a slide in there? Okay. So some of the financial incentives that are attached to tight envelopes include Energy Star or Net Zero Ready. So traditionally those are 45L incentives for residential. There's also 179D and a few others in the commercial space. We don't see a ton right now of big prevailing wage multifamily projects, but we're seeing some interesting data coming out of some regions, especially St. Louis. That's a big market for prevailing wage that's driving some of these. So I'm really excited to see what the Energy Star data is for adoption come the end of this year. We've seen a big uptake in Energy Star since that has been the driver for 45L. Go ahead and the next one, Bill. That was the one I was expecting. So when we think about why we're sealing the envelope, it's for a number of reasons, and it's not typically for every one of these in every particular case, but the biggest one is dramatic savings on heating and cooling. We've got a great slide that highlights some actual manual J data done to show the difference between a leakier and a tighter design for the same unit. If we can isolate the exterior from the interior, we have a better chance at making the house more comfortable. We have more control over that air, both temperature, humidity. We can reduce the moisture that's entering the wall system, since most of the moisture is entering on the air. Joe Steebrook and Building Science Corporation have a great slide showing a sheet of drywall, and the moisture diffused through that sheet over 30 days versus the moisture that went through that similar sheet with a 1-inch square hole cut, and it was 100 times more moisture went through. So the better we can isolate the interior from the exterior, we can help prevent moisture from entering that system. We can reduce some of the noise that's coming from outside, whether that's ambient noise or a unit adjacent. By tightening that envelope and having better control over the air, we can improve our indoor air quality in some markets out in the West Coast. Wildfires are a big concern, so isolating that indoor air from the exterior will certainly help in that regard. Places that are more urban may have other exhaust-related ambient conditions that we want to separate. And then a little bit of defending against insects and pests. If we can reduce the amount of pathways that come from the outside to the inside, that we reduce the availability of the mobility of those particular insects and pests. And then, like I was saying before, the HVAC load. This is some calculations that were done for us by a company that is PEG. It's a big national HVAC design firm as well as ratings. We hired them to do this analysis for us on a particular unit of a building in Palm Beach, Florida. So this is almost a 280 unit building. We looked at one corner unit building, a 2-bedroom, almost 1,500 square feet. And the code in Florida is currently 7 ACH. And we looked at what we could do if we took it down to 3 ACH. So the reductions on here show on just the load reductions alone, heating almost 20% and cooling load almost 10%. And what's interesting about the cooling load is that the latent load was the biggest piece of that reduction. The latent load dropped about 32%. So not having to dehumidify as much in some of those hotter cooling dominated climates can really be impactful. And this is a multifamily example. So we're only looking at 2 exterior walls and 4 interior walls. So on single family homes, we do see a larger impact for cooling and heating reductions.
Ross, do you know, in that example, did you hear of the case where then that allowed the downsizing of the HVAC that may have saved cost? Did you hear any anecdotal evidence of that?
Yes, so it took roughly a half ton off the sizing of the equipment. And it was interesting. So the sizing of the equipment, the percentage drop was actually larger. So it was about 21% for the heating and 14% for the cooling, just because manufacturers of equipment don't always have exactly the BTU load we want. They have it in sometimes half,
Right.
or if we're lucky, even smaller increments, but usually half a ton.
Great, thank you.
I'll jump back in here now and cover a couple things regarding why seal the building envelope as well. As everyone knows, a topic of conversation today that's getting bigger and bigger is carbon. Can we reduce carbon with our building design and construction, whether that be single family homes or multifamily projects or any type of building? But we did about a little over a year ago, we partnered with another company called Construction Instruction, and we did a pretty extensive quantitative analysis as well as a qualitative analysis, and looked at across 10 different metropolitan areas in the United States of America and about 4 or 5 climate zones. If we looked at different ACH 50 levels, in other words, different levels of air leakage or air tightness on a typical single family new construction home in the United States of America, what kind of an operational carbon reduction could we achieve? And what we found was that in cold climates, this is quite an extensive study. I just have one piece of the summary here, but it's very interesting that in cold climates, we can actually reduce operational carbon up to 15 to 30 tons of operational carbon that's reduced over the next 30 years after that house becomes lived in. And that's equivalent to the carbon sequestered by either 600 to 1,000 mature trees, or the equivalence of the carbon emitted burning over 1,000 propane barbecue tanks. In hot climates, we saw basically a reduction of 4 to 10 tons of operational carbon over a 30-year period. And that's equivalent to the carbon sequestered by 150 to 400 mature trees, or the carbon that's burnt using 300 propane barbecue tanks. So you can make some pretty significant contributions to operational carbon reduction by air sealing as well. And I think what we'll see over the next couple, 3 years or few years is that topic becoming of more and more importance and higher priority in part of the air sealing conversation. As part of that analysis, we actually wanted to say, hey, where are we at today? So we looked at some data from Ecotrope, which is a company that maintains a database that builders input data into, and most commonly actually HERS raters and energy raters. And we looked at 10 metropolitan areas that you're seeing here, Houston on the upper left, Minneapolis on the lower right. And we literally said for all the houses that were reported from a period from September 10th, 2022 through September 9th, 2023, so a 12-month period, what was the actual achieved ACH 50 or air leakage levels that were achieved in these markets? And the red dashed line that's vertical, what you're seeing there is that represents 3 ACH 50, which is a pretty common code that's that's adopted in a lot of these markets that home builders have to hit. And if you look in the lower right, you look at a city like Minneapolis, like well over 95% of the homes that were built there in that 12-month period are at or well below 3 air changes per hour. Having lived there myself for over 25 years, it's not surprising. It's an incredibly cold climate, the toughest winter climate of any large city in America. But they've also been focused on air sealing for a good 20 years. Look at Chicago just to the left of that, which is still a cold climate, not as severe as Minneapolis, but still pretty cold in the winter. It's about 50-50. Maybe only about half the houses that were built in that 12-month period actually achieve 3 air changes per hour or better. Houston, there's a lot of room for opportunity. Same with Indianapolis. So the point of this chart is we're kind of all over, which is not real surprising. We've definitely made some good strides in this area, but I think as an industry we can make some improvements as well. And Ross, I'm going to turn it back over to you to talk a little bit about manual, the way that we see air sealing done from the manual perspective.
Sure. So yeah, most of us that have been in the field actually doing this air sealing either because we don't trust anybody else to do it on our own projects, or we're hired to do it for other people, have relied on a various, menu of options to do that. Some of it could be the insulation type chosen. Spray foam, spray foam is a great air sealer where it's sprayed, but if it's not sprayed somewhere, it's not going to seal there. So the insulation piece can be a driver of that. We've seen that in rim and band joists a lot when there's not spray foam in the rest of the house. Can foam, whether it's for fire stopping and air sealing, we see a lot of that dual usage product. So you can see in the upper right here, there's a lot of foam being applied around wire penetrations, and I love that it's actually applied behind that electrical box to get some insulation value behind there. So bravo to whoever did that one. Again, around windows, we'll use a lot of can foam caulking in between studs and blocking plates, subfloors to plates. Sometimes we'll use sheeting products like there's a lot of two-way permeable membranes that are out there that can help in air sealing. So just a wide variety of manual products out there. But with manual products, we're got some limitations. So typically there's a lot of trades involved. The electricians and plumbers, HVAC technicians, they're all cutting holes potentially in our exterior envelope. And not all of them are sealing those up. Maybe it's not in their scope. Maybe it's something that they just skipped. Maybe they don't know how to do it. So there's lots of things that impact why we're seeing that. So there's a lot of trades involved. They're all using a bunch of different materials. Sometimes they don't know where to seal. The interesting thing that I pulled off of one installation that we did about a year ago was we had the gentleman who was responsible for manual air sealing come and check out the seal after we completed a blower door guided air sealing. And it was really interesting. His comment to me after was, where I see the sealant is about 15% of where I actually apply material. And he goes, I was just wasting so much time and effort on places that weren't actually leaking. And that was because he was just told to seal all these gaps, but not all those gaps were leaking. So a jack and a king stud, perfect example. There's probably not a big leak point on the back side of that where it butts up against the sheathing. So knowing where to seal. Inaccurate sealing as well. If you don't know where to seal and you're just trying to seal a lot, you might miss something that you're supposed to seal that isn't obvious, or you can't see or can't reach. So with all of that, it was kind of everyone's in this mindset of, I got to hold my breath and hope that blower door passes where I need to at the end. Or if they're cognizant builder, maybe they're testing along the way. I know of some builders who will sheathe their entire structure, do a blower door test, and then install one window and retest. That's somebody who is really focused on air sealing to make sure they get their details right. That's not the vast majority of builders. So manual air sealing can be some really good, but it's also got some limitations. So that's where this blower door directed and automated process really comes in handy.
And Ross, real quick, you spoke to a lot, I think, new construction examples. Just to some of those examples you showed, what do you see sort of as some barriers that stick out in existing home air sealing?
Yeah, existing home air sealing is, infinitely more complicated and more challenging, mostly because you're dealing with a structure that was built a long time ago. You're having to try to find access points to get places. You probably don't want to open up a wall if you don't have to. So what's your next best recourse? You're dealing with dissimilar materials. In some cases, maybe not even sheeted, like sheet goods on your exterior walls. Maybe you're dealing with like a 1x12 board, and there's a half-inch gap in between each of those. So existing homes are much more challenging to identify those spots to manual air seal without kind of further diagnostics to understand what's leaking and where.
Thank you.
So before we get going in kind of diving into what we do in this blower door directed automated sealing, I do want to just clarify kind of what we call, internally operational leakage. And the reason we call it operational leakage is because it's comprised of components that aren't intended to be sealed completely. They need to operate. So things like double hung windows or any window, or doors, vents, dampers, range hoods, those sort of things are all things that penetrate the envelope, but need to be opened and closed on a regular basis to operate the house. So when we seal the house, we've got to prepare it and cover up a lot of those things because the process is done based on a pressure differential. And the strength of this system is it's going to seal any place that it sees a pressure differential. It doesn't discriminate between a wall opening and an operable window. So we need to protect some of those things. And historically, the certificates that have come out of the system after we've finished have yielded an ACH result with that preparation in place, which artificially lowers it. What we have since done in the newer software and newer equipment is to allow the technicians and require the technicians to do multiple blower door tests. So they are doing a blower door test before they touch anything in the house. And then they will do a second blower door test after they finish their prep. And now with that delta, we understand the operational leakage of that specific unit and can dial in the tightness to exactly the window we want. So I just wanted to put that out there that in the past, the ACH on the report has been lower than what a rater doing an ANSI 380 compliant test would do. And now we have corrected that and been more in line with ANSI 380 and a few of the other ASTM standards.
So maybe just if I understand, so for an example of that, I'm looking at these vents and these dampers or an energy recovery ventilator. I know a lot of times those must be fully operational during the rater's test for like the HERS index rating or the ERI or the home energy score. Obviously, in your case, you don't want to destroy that equipment. So if I understand what you're saying is you're coming in, you're sealing those systems off to prevent that issue, and it may be giving an artificially better number. Then the rater comes back in, tests it with those operational systems per their protocol, like the vent, the dampers, and then there's a differential. So you have it kind of built in to say, hey, also test with that, right? Is that
Yes.
what I'm understanding?
Yep. Yeah, and we do that for not just to understand the leakage that we can address because it's supposed to remain in the building, but a lot of times, as we get customers looking for tighter and tighter envelopes, we have one top 20 US builder who's looking for sub 2 ACH across their entire portfolio.
Hmm.
And so we use this kind of as a diagnostic tool as well to understand what is the leakage that we can address. And in some divisions, we found that the leakage that we couldn't address was more than their target. And in some cases, the vast majority of those, it was exhaust ventilation dampers not performing the way they were supposed to. So for that, we identified, and that builder now is getting the value of the product that they bought, but wasn't seeing that result in the field. So it's also, for this understanding of and qualifying that, yes, we can seal a lot, but we can't seal everything in the home. And there's other components that are going to be a piece of it. And we want to understand what those are contributing to envelope leakage so we can help our clients achieve their goals.
Yeah. Thank you.
I think it's important to note too, Ross, that prior to the software and equipment updates we've made in the last year or so, that our installers were trained to actually seal, for example, if they knew they wanted to hit 3 ACH 50 or even a 1.5 or a 0.6 for passive house, we would seal a chunk below that, knowing that there was going to be a little bit of air leakage introduced back in after we covered up some of these operational leakage points. Yeah.
And what we found was that it varied widely across the different regions due to things differently. Different types of window in the northern climates, there's more casement windows than there are double hungs, which naturally leak less. So putting a rough figure on it was hard to do. So that's why we really wanted to get a unit specific quantify that leakage, because ACH can be finicky too.
Right.
A smaller unit ACH is a little more out of whack, and that's why they use CFM per square foot of envelope, which is a metric we can use native as well. So it really it really helped us address a number of issues we were seeing in the field.
Gotcha. Well, I'm going to go ahead and jump back in now and really kind of introduce us to this concept of blower door directed automated envelope sealing. Just a couple quick visuals here. You see kind of how the equipment is laid out in a typical single family home with the roof pulled off. We use a blower door, as we talked about, blower door directed. We've got sealing stations that are distributed throughout the home. I'm going to show you a video in just a few seconds that brings this to life. And then on the right, what you see is a blow-up photograph of one of our air sealing stations that are distributed throughout the home or throughout the multifamily unit or even a commercial space, depending on what we are sealing. So with that said, I want to introduce this idea too of, we are skipping slides sometimes without intending to. Oh no, I'm sorry. I did want to state that we do both single family. In this presentation, we're going to talk about both single family as well as multifamily applications. This technology is used as well many times on commercial, certain types of commercial buildings as well, but today we're really covering single family and multifamily. And just kind of our concept here is this concept of using a higher pressure interior. And we've got a picture of a balloon here because a lot of times people say, well, okay, help me understand how this really works. If I was sitting next to you, whoever, each and every one of you watching this webinar, and I had this balloon, a blue balloon in front of you that I'd inflated, I blew it up and I held it there, and I handed you a needle, and I asked you to poke a few holes in that balloon with a needle, what would happen? The air inside that balloon is going to rush outside. So the skin of that balloon is functioning like a building envelope, right? So the reason that air is leaking outside is that in nature, in our world we live in, air is always going to go from higher pressure to lower pressure. So we're basically just taking advantage of that natural phenomenon, okay? And so we're pressurizing the interior of a building or a house. We're then emitting a fog of atomized sealant that's sprayed into that building interior. That's kind of floating around the house, and then the air currents that are created by the air going from the higher pressure inside to the lower pressure outside basically just take that sealant that's wafting around in the air. It's atomized with little tiny little micron-sized particles with water around it, and it's pulled through by the air escaping through the leaks in the exterior envelope. The sealant is pulled through those leaks and seals those leaks on the way through. That's really the simplest way to describe this. What I'd like to do now is actually show you a video that is going to illustrate this. It's about 3 minutes long, and I'm going to narrate it as we go. And this will be for a typical single family home. So we start with a typical single family home, 3 bedrooms. As Ross mentioned earlier, we are going to do a little bit of prep work. We're covering designed openings that are not meant to be sealed and any operational elements as well that we want to make sure not get sealant into that air may be leaking through. So things like window sills, fireplace openings, things like that. We're then going to bring in our sealing stations. Those are going to be distributed throughout the house. In this case, I believe we've got 5. Sometimes we can do a house with as few as 3. Multifamily unit, we might do with as few as 2. In this case, we're setting up in the garage. So we're actually setting our blower door in that door that's going from the garage to the interior of the home, bringing our equipment, which includes a fan and a main control unit and a laptop outside. The laptop and main control unit are controlling each and every one of those sealing stations. We start to pressurize the house. So now we're going to bring that interior up to an air pressure that's higher than the outside environment. So that's what these blue arrows are indicating us introducing a higher pressure air inside the house. And now we're going to set up a mesh Wi-Fi network because we want to control each and every one of those sealing stations. We're measuring relative humidity. We can tell how much sealant is in each station. And then we start to spray that sealant. Again, keep in mind that the sealant particles are literally micron size and each one is surrounded by water as it leaves the emitter, okay? So we've essentially created this fog and now the air is going to start to escape outside. Cross section of the house here is showing us sealing can lights. It can also seal the electrical switches, leaks at bottom sill plates, leaks at windows and doors, anything where that air is going to be going outside through the envelope. We're continually monitoring because we're actually running a blower door test continuously, and you get results reported every 60 seconds, okay? And so we're measuring that as we go. We can see where did we start sealing. We've input at the beginning. We've input our target ACH 50. And now you're seeing examples of how this sealant literally gets pulled through the leaks and seals. It begins at the edges of the leak and then fills in towards the middle. So you saw an electrical box, now a sill plate. Next, you're going to see a plumbing or an electrical conduit penetration through the exterior wall. These are from the interior, as we've seen. So that's how the sealant gets pulled in. Again, we're continually monitoring this. We know what our end ACH 50 goal is. In this case, it was net zero, a target of about 1.5 ACH 50. So when it's achieved, we simply shut the system off. We remove our equipment from the space. We're going to remove any of the prep work that we did so that other trades can come in. We're about 30 minutes after we're finished and get right back to work. And now you get an envelope sealing report. There's a few things that show up in here that where we've taken our logo off, but this is the seal report. It says, where did you start? Where did you end? And essentially seal time typically for a typical single family house is 60 to 90 minutes. Counting the prep work and the takedown, we're going to be on that job site anywhere from 3 to 4 hours from the time we roll onto the site to the time we roll off. And then the seal's done, you actually have written proof that you've actually achieved that ACH 50 that you're targeting.
Hey, Bill, I'm going to jump in real quick because we have one question that was asking whether or not we can apply this from the exterior and pull it in. So the short answer is on the exterior is probably not, because we do need to keep that sealant confined so that it can come in a quantity large enough for it to seal. We are currently playing around with adjacent spaces to the interior, something like a crawl space or a garage or an attic, and evaluating the effectiveness of that. So depressurizing the living space and bringing the sealant in.
So next, what I'm going to do is actually just take us quickly through this 4-step process. You've seen it illustrated or animated in the video, but I'll talk us through it. So we start with prep work and setup, then we pressurize and begin sealing. We're monitoring that whole time. We continue monitoring and then finish sealing, and then finally certify the seal completion and cleanup. So just to give a little bit of life to each one of these steps. Step 1, prep and setup. You can see some photographs here. We've got the equipment set up outside in the upper right. Here's a sealant stations that's brought into the inside and set up inside. Here you see an example of someone basically covering the sill of a window. The reason that we're covering some horizontal surfaces is that the sealant will only stick to leaks. It doesn't stick to any vertical surface. However, when we turn the system off, it can sometimes settle on horizontal surfaces that we don't want it to settle on, because it's going to fall when we shut the system off and the inside higher pressure air essentially dissipates. The remaining sealant, the air just falls to the ground. Most commonly when we're doing it here in new construction, we've got a subfloor down, and there's all kinds of other debris that are going to be falling on that floor before they come in and do finish work. So the builder doesn't really care that we've got a little bit of sealant residue that dries after about 30 minutes into a dust-like material. So, but we do want to protect some things that just make cleanup and follow up easier. So that's why we're covering windowsills and some other things. Then we pressurize and begin sealing. You see in the lower left a picture of one of our sealant stations and a close-up of the nozzles. You can see how fine that mist or fog is that we put out. We're going to input our target ACH 50. The computer is controlling everything in our software. And then again, we're spraying that atomized sealant. Now, again, we're doing that we're running a nonstop blower door test. So and the blower door is actually guiding the sealant, right? Because it's pressurizing the inside of the space. So we're monitoring that sealant nonstop via the laptop computer. The software is regulating the entire process and records all the data. Again, progress reported every 60 seconds. We do then verify that the targeted ACH 50 is achieved. That then shuts off the system, and we generate a seal report that shows where you started, where you ended, other facts about the seal that was done. We remove protective coverings and equipment from the interior, and again, construction work can resume after 30 minutes. I'm going to turn it back over to Ross, who's actually going to take us through some before and after photographs of this system and the sealing that it's done, as well as some other information about sealing, etc.
Real quick, Bill, if you go back to that last step there, I'm curious, is there a sort of new piece in this step before you remove the protective covers and equipment, or I'm sorry, after you remove those? Is it now my understanding that blower door test is being done again by people who understand how these pieces fit into the energy ratings? Is that correct to say?
Yeah, Ross, you want to take that?
Yeah, so we have the option to do a final depressurization or pressurization test out in kind of ANSI 380 conditions.
Yeah.
So typically, the technician will do that.
Great. And is there a space on the report where it sort of can show up and say, here's where it was with that and differentiate that?
Yeah, so we have a space that we can quantify that operational leakage,
Yeah.
so that can be on there.
Yeah.
We don't, on the typical seal report, we don't have the ANSI 380 language, just because not all of our technicians are certified
Sure.
with either the BPI or ResNet. But for those that are, we can unlock a certificate that has that information, because it's using their credential
Right.
and our equipment, which is ANSI 380 compliant. So
Yeah.
we do have that ability as well.
Yeah. Thank you.
Okay, Ross, you want to go ahead?
Yeah. So these are some of the photos that, there's a couple slides like these that show the sealant, in real time. And I will fully admit that electrical box cutout is darn perfect, and we're not going to see that in the field on a consistent basis. But the sealant in a typical installation of an hour to an hour and a half is probably going to seal a leak somewhere in the 1/4 inch, maybe 3/8 of an inch range. We could seal much larger leaks. It just takes much longer. And if those leaks are readily available to us to address, a 1-inch gap is better sealed with a foam material, and let us come in and grab the rest of the gap between the foam and the substrate. So in this one, you can see the electrical box. It got sealed pretty well all the way around the edges. And then even inside the electrical box, you can see the knockouts got sealed, the screw holes got sealed. Anything that is open to that pressure differential is going to get sealed.
Right, and I think that's what's really something here is when we've had builders, after we do a seal, they'll look and they'll literally shake their head and say, nobody seals the cutouts or the knockouts in the back of the electrical box, right? But when you think about how many electrical boxes are in a typical new construction home now, that really adds up to a decent amount of air leakage.
And on electrical boxes, the electrician's going to come in and do their finish install, and they're going to be pulling on that wire a bit. The sealant itself will retain about a 20% flex. So that should accommodate the natural settling of the unit. Hopefully, if it's settling more than 20%, we need to talk to our builders and our framers a little bit more about putting things together tighter. But so as long as that electrician isn't, yanking that wire out of the wall to get more slack, that seal should remain intact. And these are a few more pictures of just some other seals, some wire penetrations, a few more electrical boxes, one in the ceiling, a couple in the wall, door jams, where the drywall meets the framing. Sometimes that is the beginning of a leak path, especially where that ceiling meets an unconditioned attic or a vented attic assembly. The washer dryer panel on the bottom right there, another example of leakage we see. The middle one in the bottom is a little bit different, so that the seal was done at rough. So this was pre-drywall, and this is likely because the attic was either unvented or that they installed the sheetrock or drywall to that attic prior to the seal, so we could seal the exterior wall plane. And so the sealant isn't, like Bill said, it's not going to coat everything. It's not like we're going in and spraying a sealant on all walls and surfaces. It's really only sticking where the leak is. And this is actually a photo I took of a job on Martha's Vineyard circa 2020, 2021. And in this one, you can see there's a whole bunch of jacks and kings that line up right here in between two windows. And on each side, there was this nice small little leak and a gap that was, open just a little bit. And then in the middle, there was a tiny bit. So you can see clearly that there's not any sealant on any other parts of that. And that's one of the things that's really the strength of this system, is it's only going to be deposited where there's a leak. And the sealant itself, it is ultra low VOC content. So it's certified Green Guard Gold by Underwriters Laboratory. So that means that we can put it in places where there's high sensitivity, schools, hospitals. I did see a question about a school in the chat. We will address it. there's a whole lot of other things that it meets. I will say that the flame spread and smoke developed index are both 0 for this product. It does not have any fireproof qualities, so we can't use this for fire stop material, but it is not going to contribute to a fire. And we're UL certified for, oh geez, I forget all of the assemblies, but it's pretty much all wall, floor, and ceiling assemblies.
Ross, real quick on the air quality, and
Yep.
I don't know the testing protocols per se of Green Guard or NGBS, National Green Building, but I'm curious if you, now that there's the proliferation of these air quality monitors, like everyone can get an air quality monitor and we can now know, excuse me, our air quality. So I'm curious if you've seen anything where either an existing structure, this was installed and you have pre and post. I would think it'd be really VOCs here. I can't think of anything else really. Or even on a new construction home where you might just have someone monitoring the air quality. Have you seen any of that, or is that part of any of this testing data?
So yeah, the VOCs are ultra low, and we do have testing for that. Interestingly, I did get a call a few weeks ago from a project superintendent for a house that was done as a demonstration house for that builder. And the homeowner bought an air quality monitor and said, hey, my carbon dioxide levels are really high in this house.
Right.
And they thought, well, we tightened it up. It was the only one we tightened up. Yeah. That must be why. And so I said, well, let's look at it. And I said, what's your ASHRAE 62.2 ventilation? He said, what? and I said, okay, well,
as they should say.
let's look at that, because I mean, this house was only taken to 3 ACH. It was not ultra tight. So so we looked at it with exhaust fans, and because this homeowner was asking the builder to put in a whole fresh air ERV HRV ventilation system. And I will say that if the home does not have the correct amount of ventilation for the air tightness that you're shooting for, that can become a challenge. Sure. And typically the guidance we give to our installers is that if a builder is asking you to take it below 2 air changes and they do not have a plan to do an ERV or balanced ventilation, that is probably not a project you want to take on. Sure. So we do offer that guidance to our builders, and we ask them to work with the rater to make sure that the rater knows what specifications the envelope leakage is going to be, so that they can plan to coordinate with the builder for the correct ventilation strategy.
Thank you.
Hey guys, I'm going to deviate just a bit here. Shane is our star installer who is on the webinar with us today, and he is very customer service focused professional. So he's had something come up in the field that he's going to need to get to a little after 1 p.m. So I'm going to skip forward a few slides and just get us to an area where Shane was really kind of leaning in, if that's okay. We can come back and cover a few of these slides after Shane needs to leave, if that's okay with people.
Yeah, I think Bill, both you and I can stay past 1 o'clock. So we can.
Yeah,
please do. Yeah.
Sure.
So we're going to skip through these sections again. We'll come back and cover these. But let's begin. And Shane, you've got both you and Ross have really good experience here with new construction versus existing homes. So maybe just take a couple minutes to talk about that. And then we've got some really cool kind of lessons from job sites, a slide or two after this that we can speak to. And we've got some great photographs of seals in existing homes as well. Ross, do you want to kind of start off and Shane lean in?
Yeah, so I think we touched on some of the differences between new and existing homes. And I think, Shane, you'll probably agree with this, that one of the things that is the big driver of the differences is we just have more to protect. There's more finished surfaces, especially horizontal with flooring, that we want to protect from the sealant, falling out of suspension in the air column. And then the more we cover up and the more we protect, there might be leakage behind that floor that we can't address now. So there's kind of a diminishing returns with how much you prepped, how much you can seal. And Shane, I'll let you take it from here and talk about your experience.
Yeah, that's the 100% the challenge is the more you have to cover, the more you could potentially be covering leak points. And then, it's just, there's liability involved with that too. Countertops, flooring and stuff are not cheap. The equipment and stuff like that. And we want to be very careful with everything. And it's obviously just from like a dealer standpoint, the best results will come the sooner that you can do it in the building process. And the soonest you can do it in the building process is once there's a lid. So as soon as you can get a lid, it's the best. But I noticed some people had asked questions about in the chat about doing it in remodels or the finished surface question. Also, hopefully we answered that. But I've done remodels. I've sealed my own house with all of my wife's clothes still in the closet, and I'm still married. And I've sealed friends' houses that are lived in. It is a challenge, but it's absolutely worth it. My house is a lot less leakier now. My air conditioning doesn't kick on constantly in the summertime. It's made a huge impact on that. It's not a huge market, the remodel world, but we've definitely done quite a few of them, and it's totally possible to meet those goals in those structures versus just the framing of the new construction stuff.
And Shane, I think it's important. I mean, really good points you guys made about, the more you cover up, the more you might be covering up some leak points. But I think it's also cool to point out that, when we think about this concept of higher pressure air getting to lower pressure air outside, air doesn't discriminate. So the technology itself still works great at sealing leaks, whether it's new construction or existing construction. Just many times there's a lot more prep work. And I threw these pictures up on the screen, Shane, that you shared with us. Maybe you can speak to these in terms of, how you did, what kind of prep work or protection you did. You can see our equipment set up outside on a deck, but maybe speak to these interiors. And then we've got a couple more photographs on the next slide as well.
Yeah, this was very early in my career. So very afraid of ruining anything. And, I would do it very differently now. There's a lot less that you have to cover up, but, it's just carpets, covering up the carpet, and then making sure that you don't go too close to the wall so that the air can still get under there. Because, interior and exterior walls are huge leak points. A lot of people think it's always just the exterior of the house that leaks, but the interior walls run right up into the band joists or right up into the attic, and those are just highways for air. There's very little attention that's paid to by the other trades a lot of times in sealing up those around the band joists, because nothing really gets seen. Once it gets covered up, it's kind of out of sight, out of mind. But the one here on the left, this is like a new construction here in Tennessee that they had already gotten all the cabinets in, the flooring was all in, and this thing was like at the finish line and realized that they needed to be tighter. So we went in and we're totally able to cover everything up properly and get people moved into this house the next day once we got it passed. So it takes a lot of experience and skill to know where to prep things, but it's like the whole process is automated once you get it set up right. So the sealant does not discriminate. It will find the leaks and it will seal it in real time.
It's okay. I'm going to jump forward to our lessons from job sites that maybe you guys can speak to. We identified ahead of time some key subtopics that were, kind of were some of these learnings for both Ross, who had been an installer for a few years, and Shane now, who has been an installer for a few years as well, identified. So if you guys want to kind of have at it and talk, maybe, tell some stories from the field about some of these buckets of learning.
Yeah, I'll touch on a couple of these. A lot of it, like just in sealing my house, which was built in the 80s, and sealing the new construction homes today, there's a lot more electronic devices. Everybody needs a phone charger next to their toilet and their bed. And so there's 30 can lights in every house. And so there's just a lot of holes that people don't realize are all leak points. So there's just a huge amount of opportunity to like lose all of your conditioned air through all of these new holes that we're introducing. And then we spend a lot of time walking through houses before the drywall, before the insulation, to take a look at the framing, because once that drywall's up, I have no idea what's back there. And what we've noticed is a lot of people that are doing the work of the manual sealing for codes or inspections, a lot of times they're just kind of doing what they were told. They're not walking the house with the mindset of air leakage. They might be thinking about fire stopping. They might be thinking about water leakage, but air is just, it goes up, down, left, right. It can go anywhere. So a lot of times they don't really see what they need to see to catch a lot of this stuff. So, you know, this process just takes the human error, the omission right out of it.
Yeah, I think that, you know, one of the things that's great about doing a system like this is that it can hit the things you can't reach or can't see. One of the things we see a lot in multifamily buildings that are multiple floor, so townhouses, a lot of times the staircase is on that party wall. And I would say 11 out of 10 houses that we go into, that staircase is tremendously leaky. And it's because it was hard to get a physical component up into the, you know, the top corner of that staircase underneath the stringer. So just the physical limitations of being able to put something there means that, you know, having a product like this, it really makes that easier to address. You know, we've had a couple of questions about sealing it at rough pre-insulation versus after drywall. And the biggest driver of that is a vented attic assembly. If there's a vented attic assembly, we can seal it rough, but we need some delineation, some separation between the attic and the conditioned space, and a temporary solution like poly is not going to hold up. We're installing at pressures of 100 to 200 pascals, and that poly is just not going to hold up. And most builders either can't get their drywall crews to split the install, or their drywall crews won't. So typically, that's the determining factor as to whether we can seal before insulation or after. We love to seal before insulation, because if you seal that exterior plane, doesn't matter who cuts a hole in the drywall after you're done, it's not going to impact the envelope leakage. So that's one of the pieces that we would like to see more of, but we just unfortunately don't. And then, you know, I'll speak again to the kind of the diagnostic pieces of trying to help a builder achieve a tightness. Is they don't know that something is not performing the way it's supposed to. Whether that's a window assembly that got put in incorrectly, or it might be coming from the manufacturer, damaged or otherwise compromised. Ventilation systems, duct systems, there could be something there that's not performing the way the builder intended. And so for us to be able to go in and identify that helps the builder get the value that in most cases they've already paid for.
Shane, when we were chatting the other day, you had mentioned our last bullet here, things that help achieve a better seal. There's not a, you know, this technology is not a high maintenance technology for a builder, in that, you know, a list of a whole bunch of things needs to be done before we show up on the job site. But you, as an experienced installer, have learned a couple of things that you now do that make seals go faster, better. And one of the things you talked about was using your little blower. Can you talk a little bit about that?
Yeah, I mean, probably the biggest thing that we realized in prepping a house to get the best quality seal is just to open the pathways that the sealant will likely use, which is under the baseboards, around the outlets, around the can lights, around all the penetrations that are designed to go in there, the windows. And typically coming in after drywall means that there is drywall dust on everything, just piles of it. So to clear those areas away, to give the air path to bring the sealant through these places, is just a huge help. Because if you just leave the dust and stuff like that, it's you know, it's just going to take up on the dust and wash right away. But you know, it's not something that we've ever asked our builders to do for us. We've never said, hey, you need to have the house spotless when we come in there. It's something that we know where to clean. And you know, typically after drywall, they usually have some sort of a rough cleaning anyways to get a lot of that stuff out of there. So you can always work with them to schedule, you know, post that or whatever. But it is a huge plus in keeping the pathways open for the sealant. Yeah.
Well, thanks, Shane. I know you've got some customer focused work that you need to get to. So, Bill, do you want to go back to the rest of the presentation, or do you want to do the Q&A? We'll do the Q&A after, I guess.
Yeah. Well, Brett, what do you think? We can probably cover the rest of what we were going to cover in less than 5 minutes or less.
Yeah, I guess before we jump into that, I just had a couple things here,
Sure,
and then
sure. Perfect.
and then we can go from there. So, just as a real quick reminder to everybody, this technology that we're talking about also applies to duct leakage, and can be done in the same way to solve the same problems with duct leakage. So if you all didn't catch it, we have a session on the automated duct sealing technology, the same type of technology. So we hope you'll go and watch that session if you want to learn about how to solve these problems, which we also face in our world of duct leakage. And then just a real quick reminder as well, this session is being recorded, so it'll be posted in the next couple days on our YouTube channel, so you can head over there and look then, or you can go there right now and click subscribe, and you'll get an instant update when the session is available. And then also just real quick, for those of you watching this session in the future, you can take your quiz with an 80% passing rate. You can receive your continuing ed. For those of you here live today, take that survey that pops up. Check your spam at certs@gutenbergcerts.com in the next couple of days, and you'll receive your certificate as long as you've been here for the entire CU approved hour. And before we get into the rest of the presentation and more of those slides and questions, a huge thanks to our board of directors, our volunteers, our executive director, Jose Reyna, our nearly now 400 members. We're almost there, and we hope you can help us get there soon. We're almost, we're getting there, for all their support, and our top tier sponsors, such as Ream and Build Equinox, and everyone who's making technologies to help you make greener and more sustainable homes. So yeah, I'll hand it back to you to wrap up the rest of the presentation here, Bill, and then we'll dive into formal Q&A. So.
Sounds good. Can you guys see my, I think I need to share again so we can get my.
Yeah, please do share again.
Gotcha. Okay, are you seeing the slide again?
Yep.
Okay, very good.
So I think you just need to put it into presentation. Oh, we're seeing the notes on the side.
Gotcha. Okay. A couple things. Somebody had asked this question anyway when we talk about new construction versus existing. They said, could we do existing multifamily? Just want to show a quick example. This is in Rochester, Minnesota. It's an affordable housing apartment complex that was under construction. There were about 208 units, if I recall right, that were being built. They had 160 units finished, and they were failing blower door tests. So they weren't actually able to, and they had families waiting to move in. The builder and developer is actually paying for hotel rooms for multiple families at that point in time. So we got called in for what we call essentially a help out or a rescue job. You can see a picture on the right-hand side of the screen of what the finished unit looked like. So all finishes were in place, appliances, light fixtures, and so on and so forth. And essentially what we do is set up our equipment outside on the left, just like we would if it was still a new construction job. But then we begin to do the prep work, which you saw some of this in Shane's photographs of a couple of existing homes he's done. And as he mentioned he had a lot more prep work, and even the way he was doing prep work was right after early in his experience as an installer of this technology. So with more experience, people get a little more accurate and precise with where they're doing prep work. Here you can see where we've covered up the carpeting and some of the operable mechanisms on a double hung window. We're protecting a couple things on the door. Again, more of the floor finishes, but then notice that we had a ceiling fan in the living room. So we bagged that. We also bagged some light fixtures. You can see where we're covering finished kitchen cabinets, but we were able to go and essentially seal all 160 units that had been finished and weren't passing blower door tests. Did that very quickly for the developer and builder, who was then able to get certificates of occupancy and get the families moved in. So quick example on that. I just wanted to cover a bit too, just quickly, so that you understand kind of the multifamily aspects of this.
Hey, Bill, can I jump in one point
please.
there? We did see a question about the multifamily. If it's existing multifamily and we don't have kind of what I would call construction control over the adjoining units, depending on what the, how the leak is interacting between those two units, there is a chance that our sealant material will move from the unit we're addressing into an adjacent unit. So for occupied units on either side, it's a little bit more of a case-by-case basis.
Right. And there was a U.S. Department of Energy study that was finished up about a year to 2 years ago. And that study is out there on the internet for public access, where they did existing single family homes as well as existing multifamily, and did a lot of, looked at a lot of different alternatives and options, and then reported in that study. But just a quick cover a little bit about multifamily. A lot of what needs to happen in multifamily is compartmentalization, where you can see on the upper left photograph here, image, that we're literally trying to isolate one unit and seal that, not just from the exterior, but seal it from common spaces as well as other living units, as we talked about earlier. And in the lower right, you can see where we're fogging that space. We've got, in this case, there's 3 sealing stations set up in this multifamily unit. And if you go, we were using a blower door, the same equipment, higher pressure inside, going to lower pressure outside, whether that's the unit next door or whether that's a common space or the exterior. And then here's an example of a cross section of the building showing with kind of 3 apartment units. The one in the middle is the one is being pressurized and sealed. There are unpressurized units on both the left and the right. And so we're going to seal things like the leaks at the bottom plate, data junction boxes, electrical boxes, a number of different things. If there's a plumbing waste pipe that's, as you can see at the top of this image, we're gonna seal that as well. So, and we do the same use the same software, run the same blower door tests, or we're reporting results every 60 seconds, just like we do a single family. So just wanted to kind of get those up on screens quickly. Maybe now what we can, and benefits that are unique or more unique to multifamily would be if tenants are paying the heating and cooling bills, there's real energy efficiency benefits for them, or for the individual tenants of the individual units, but also big plus in terms of many affordable housing developments and buildings have federal, state, or local requirements for indoor air quality. So sealing the air leaks is a way of really improving that indoor air quality drastically, whether those are odors from cooking or legalized smoking of different substances, or whether it's allergens. Also helps reduce sound transmission, and then really helps reduce pests going from one unit to another. So I think now maybe what we can do is focus on Q&A and just cover maybe some of the questions that we did answer during the presentation. Does that sound good?
Yeah, there are a lot of questions in there, and I don't think we're going to get to all of them today, but let's try to, and a lot of them I think are the same questions. So let's try to get to some. I want to go back to something that you pointed out, Ross, that stood out to me on multifamily, about what you had mentioned about the ability for the sealant to get maybe sucked into the other unit. It really kind of piqued my interest and stood out to me as interesting, maybe troubling. But
Right.
Before I get to that, though, let's take a step back here, both on even multifamily and single family. And someone made an observation. One of our members made this observation in the chat, which I appreciate. And that is, you mentioned a rescue project earlier. And so, this is an experience I've personally had, consulting on projects where these technologies, both for the ducts and the walls, were deployed after the job was done because they were trying to hit the air leakage target for their green building label, right? And certainly it's not fun to have to come in. Nobody wants to be introduced to this technology at that point because they're very stressed. They want to turn the project over. So my question is, do you see some strategies to be proactive rather than reactive? In that, I mean, let's say you're doing a project. Have you seen this get into maybe the contingency at the worst? The best would be, yes, we're just going to do it. But maybe the second best being, do you see consultants kind of coming and saying, look, we're going to put this contingency in, and should we get to the end and we do your rating and you're at 4, but you needed 3, or you're at, 0.45 enclosure, right, in multifamily, but you need 0.3 enclosure. And now you know this is coming and you're going to have to activate it, right? You're going to spend those contingency dollars and away you go. Have you seen anything like that? Or can you, speak to that issue at all?
Yeah. So actually when I was an installer, we were what I would call the backup plan for a number of builders. But using that, I would say that I recommended to them that once they get to a point where they can physically test the unit, that all the sides are on, they should test it, because if they need us, that's the time for us to go in. I will say the price is dramatically higher going into a rescue job. In some cases, it could be 3 times as much because we're having to cover up more things. It's just more labor that we're not really geared up to do. So yes.
And to clarify, I assume there's a difference between a rescue post move-in and everyone's got all their stuff in versus a rescue of like, oh, hey, we're doing the final test. We have a problem. We got to get them in before moving. Would there be a big difference there?
Between those two, probably, a decent difference, but it's still going to be, much more expensive than just doing this at the correct phase, which
pre-drywall.
In the case of a vented attic assembly is somewhere between first coat of mud and flooring and cabinets.
Yeah.
So that's a good window. But yeah, I would say we have been the backup option. I would say if you're going to take that approach, definitely test as soon as you can, so that if you need it, we can deploy it at the correct time.
Yeah. And then, so yeah, getting into that multifamily concern, does that issue you brought up about it being pulled into the other unit really occur on these existing, or is this new construction, or what do you need to be mindful of there?
I have seen it on existing. So, and there's a great video for those of you who know Nick Schiffer, who's a builder in Boston. He puts out some great YouTube content. He looked at doing this, and he was really smart about it. He was doing the top floor unit of an existing building, and he and the aero barrier technician were thoughtful in that they used theatrical fog and did a test. So they pressurized the space, deployed the fog to see where it would go. And interestingly, if I recall correctly, it did not go to the unit directly below it. It went to the unit 2 floors below it. So kind of this air path it's hard to say where it's going to go, what it's connected to, especially in existing buildings. So that kind of diagnostic work can prove useful to see if you can actually seal it with minimal impact to the adjoining units.
Yeah. And so ultimately, if you were doing an existing building, you're really worried about maybe evacuating people at a larger scale than just maybe the adjoining unit, or even you definitely maybe want to evacuate the adjoining units, right? I mean, is that protocol that's in place?
Typically what we would do is we would basically put in a scrubber fan. So for those of you who, during COVID, we saw the box fan with filters on all the other sides. That's exactly what we're doing. We're sucking whatever comes in out of the air before it has a chance to settle. The other path is to do kind of a guarded install where you pressurize the adjoining units to the same pressure or slightly less than what you're using. The challenge there is you're really only sealing to the outside, but that may be the concern, is just to the outside and less unit to unit transfer. So like I said before, it's kind of a case by case.
Yeah. So thinking about the durability and longevity of this sealant technology, kind of 2 things come to my mind here. The first one, a lot of questions coming in: how long is this going to last? And is there like 5-10 years down the road you want to reseal to maintain your air changes per hour? But then I think of it in the other direction, and I think of the idea where we want to get to a future where maybe someday we need to deconstruct the home or the building, and when we deconstruct it, we want it to be more recyclable. Is something like this going to prevent or make that harder to do? We think back in the future, I wish they hadn't done all this stuff, right? Lead, all that. Not that this is going to be that, but now it makes our job harder to deconstruct these buildings. So speaking to the longevity, both on the positives and negatives, can you, briefly talk about that?
Yeah. So the material itself, we haven't been around for 40 years, but we've done the industry standard advanced aging testing for a 40-year durability. And
it's actually 50.
It is 50?
Yes.
Yeah, it's been a long day so far.
And Ross, real quick before you go into a little bit more technical information, one of the things I always like to kind of talk about very briefly is, all the different major caulk manufacturers. This dries like a caulk, essentially, right? That's where it nets out, is as a caulk, right? We're just applying it and installing it in a very different way. Like any caulk manufacturer who's been around for a long time, every year they're coming out with new formulations or a caulk that can do this, or we change the formulation. And so that caulk has never been used before.
Right.
And so they have these advanced, these aging, these tests done by independent labs, and we had the exact same test done. So we end up achieving the same durability rating that any caulk on the market is.
Yeah. So the testing subjects it to cycles of extreme high and low temperature, flex, all of those things, and then we measure the how well the sealant maintained. And Bill, correct me if I'm wrong, it was less than 0.1% in degradation, I think, over that
Yes.
test. So we're very, very confident that the sealant itself will remain unless it's disturbed by somebody doing something active. To your point about deconstruction. And when we think about the product itself, we're waiting on the EPD results, the official stuff to come through. So for those folks that need a product declaration of like that, we're excited that we're some of the first folks doing that.
One of the first in sealants. Actually, it'll be done in the next 30 days. So it's one of the projects I'm working on.
Excited about that. It is a water-based acrylic, so there's really not much there. So when you think about deconstructing and recycling, we have to separate all of our gypsum from other streams. We're not in kind of that space. So as far as deconstructing, and the other thing I'll note about that is there's really not a ton of our sealant going in there. So the sealant itself comes in a 5-gallon bucket. It looks kind of like milk, but it's about 80% water.
Yeah.
And all of that water content is basically so we can deliver the sealant through the tubes to the nozzle. When it mixes with compressed air, that water content evaporates off. So let's say a typical 2,000 square foot house is actually really only utilizing 3 or 4 gallons of sealant, which once the water content is off is kind of less than a gallon of actual material. And it's spread so thin throughout the house at all these different leak points that there's really not a huge amount of appreciable material in the space to really be concerned about, the material itself. And there's far more latex paint that's in your house than you would have sealant.
Yeah, and just one final quick note on longevity. So one of the very, 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 very first houses that was ever sealed with this technology went back 5 years later and did a blower door test. And after 5 years of the family living in the home, opening, closing doors, slamming windows, living the house, going through weather cycles of 5 years, they retested, and we were within something like 0.1% or less of the air leakage that was measured at the conclusion of the installation of this sealant.
And I believe, Bill, that result actually, I think it might have fallen in within the temperature differential calculation of the test of itself. So really very little appreciable movement. So we have a few houses like that we have the ability to go in and retest. Not every homeowner is really excited for us to come back and check every year with a blower door, but if they're out there, we'd love to test them. Sounds
like a great pilot study project. So here's a call to everyone who's interested in doing that. I know we'd be interested in seeing something like that happen. So EPD, so embodied carbon. So you're saying is when people are doing their embodied carbon calculations, they can now kind of throw this into the mix as far as understanding the impact of that, correct?
Absolutely. Yeah. No, we've actually taken an active role in the whole idea. That's why we did the carbon study we did a little over a year ago. And we focused there on operational carbon, but knowing then that we wanted to be able to speak to the embodied carbon that we leave behind in a house or a multifamily unit or a building. That's why our EPD is, at the very, very last stages. It should be done hopefully within 30 days from now. So,
Now, obviously, everything in anyone's mind with anything these days is cost. And obviously, to say, maybe you can say it's X per square foot if it's, done during the phase you want it to be in, right? That sort of pre-drywall stage, or it's, X per square foot if you do it in the final stage, or X per square foot if you do it in the hey, they've already moved in stage, right? Maybe you can say that, maybe you can. I don't want to hold you to that, but I always think of his cost as relative to something else that you could have done, a choice, right? An opportunity cost. So I assume somebody can make a decision to employ an army of air sealers and caulkers and all that, or they can do this, or or they can use spray foam, or they can use maybe what I would argue a more sustainable material with lower embodied carbon in your product. So just speak to me a little bit in the way I guess you prefer on the question about cost. There's a ton of people asking it. It's obviously on everybody's mind. So
it's the short answer is it's going to vary. We
Right.
do not set the price that our installers charge. They pay a license fee to us to utilize the product. So it varies by market depending on your labor costs. It will vary depending, a production builder is going to get a different square foot price than a custom home builder doing 1 or 2 a year. So it will vary by market. It will vary by conditions, how tight you want to take the house. If you're looking for passive house level, that's going to be a different price than 3 ACH. So if we're just talking, ballparking 3 air changes an hour, a typical price that we have seen in the market is somewhere between $1.15 a square foot for a small volume builder. Production builders, I would say it's probably somewhere between 85 cents and $1. So again, it's going to vary. Your mileage may vary,
Right.
but that's kind of what we see in the marketplace right now. And I will say that when I was an installer in Massachusetts, starting in 2019, my price was somewhere around $1.50 to $1.75 a square foot. And now that same company is probably in that dollar-ish range. So as far as I'm aware, it's one of the only products in the last 5 or 6 years that has gotten cheaper.
Right.
Yeah.
And I'd say for production builders, even like a regional production builder or a metro area based production builder, we do see a lot of times the cost being towards that 85 cents a square foot, more towards that end. And then you have to think about, okay, what don't I have to do now? Right. So you look at equivalent cost and say, if I don't have to do as much manual sealing, I can back. Many times when the DOE did a study on this in new construction single family homes in the state of Minnesota and California, they had basically calculated that with a typical builder building homes, they probably had 2 laborers spending the equivalent of 2 days each. So that's, basically 4 days of labor, manual labor, right, that they had to pay for. Plus, about $1,000 in material cost for cans of spray foam and tubes of caulk. That many times you can eliminate most or all of that. Most of the time, you eliminate most or all of that when using this application.
Sure. Yeah.
And I will say that too. There's a couple questions in the chat about finding contractors in your market. If you go to the aeroseal.com website, we have a feature to find dealers, and you can do it by your location. And definitely reach out to any of those dealers that are on that map have been trained and certified by us to do this process. So feel free to do that. A couple other questions I've seen on here.
Are there on that note, real quick, Russ? I mean, are there those who are not trained and certified by you who could just go pick up your equipment and do it that people should be watching out for?
No.
So you can't acquire the equipment.
Okay.
Our sub-license agreement, prohibits people from doing that. We had one case where the equipment was repossessed from somebody who had a bank failure, and that equipment was floating out there, but nobody could use it because
we snagged it.
Well, it also it communicates back to us, so it could not operate.
If people want to do this work and get trained, is there a cost to them to do that?
Yeah, so there's you're buying the equipment, and there's a whole package to that. If people are interested in that, they can reach out to us, and we can give them more information on that process for sure.
Yeah.
I mean, I will say that when I was a HERS rater, I saw this product on this old house, and 2 weeks later, I had opened up my wallet and become an installer because I knew I knew a whole lot of people that could use it. So. I imagine some of your folks are in the same boat.
Well, you make a good point because and on the last event we did on the duct sealing technology, we had the energy rater, and again their point was, and we see this, you go in and you're really just giving people bad news many times, right? You're sort of the bearer of bad news, and it's like and then it's like, well, now what? And so I like the idea, and I think some energy raters resonate with that, where they can now offer this, but it does set up a sort, and someone noted this, a conflict of interest potential where you as the rater in most cases can't be also the installer. Now there are exceptions to that for nonprofits and other things. But how do you sort of straddle that line? Because it's like you want your installers to be doing the ANSI 380, is it? I don't.
Yep.
380. 380. You want them to walk away with. I would argue you want them to do a 380 every time and have that.
Mhm.
But we also still need to then bring in the third party rater, who would, I'd imagine, again, you're in good shape if someone who knows what they're doing is installing your product. Then they don't have to give them the bad news, right? Because
Yeah, no, and I will
do you
say,
see the raters like taking that data and going, look, you know what? I'll trust you. I'll put it in, and then I can reduce my costs for doing the blower door test. Like, and again, I see some raters hearing that and they're cringing right now. Like, no way, Brett. So,
100%. So we try really proactively to engage the rater community, and try to just meet them where they're at.
Yeah.
And in some cases, there are raters out there who are small operations, maybe 1 or 2 people, and they say, hey, if somebody who is trained as a rating field inspector also happens to be an aero barrier installer and wants to give me a piece of paper that says, hit this, and I trust them, and they want to accept that, and it's kosher in the Resonate ecosystem, fair play. I will say that most of our interactions with raters are more about that pre-construction value engineering and understanding how the builder is going to achieve whatever target they need, whether it's code or program. That's really the strength of the relationship, and understanding that the builder is engaging a strategy designed to be successful the first time. I'll give you an example. Avalon Bay Communities built a building in Boston. They finished it a year or 2 ago. 180 units, and they did not have the natural gas supply available to be able to heat all of those units with natural gas, and they were forced to go with heat pumps. And to make that cost effective, they needed to compartmentalize and really separate those, not just from the inside, but also the outside. And they engaged us to do that. And we had a rating company come in to verify that after the fact. And that was the first time for that builder that every single unit passed the blower door test the first time. So kind of the way we see our relationship with raters is very much a partner, and however they would like to work with us is where we're going to meet them.
And that's going to be very important to get everybody engaged early. So we are certainly over our time, but I appreciate you both for sticking around and answering some questions, engaging in this dialogue. Before we wrap up real quick, where can people go? Just a reminder to learn more, maybe hire somebody, maybe become an installer themselves. Where can they go to learn more?
I'd say go to aeroseal.com. That's our company website, and you'll find any and all information you need. We also have a couple YouTube channels, the AeroSeal YouTube channel, where they'll find a lot of good videos on the duct sealing, as well as Aero Barrier YouTube channel, where you'll find good videos, both for the single family animation, multifamily, and others. And real quick, I just want to say, because I saw a few questions peppered around about the sealant itself. Do people go inside? Our installers actually regularly go inside the home or during the space during the seal. They do not need to wear a Tyvek or a hazmat suit. All they wear is what somebody who's painting would wear, like usually eye protection and a respirator. Like I did when I was painting my house, my single family house. I wore one of those just to be safe. And that's what they wear. They quite often go inside just to adjust locations or orientation of seal stations, to refill sealant inside a seal station if it's needed, and things like that. So very safe sealant. That's how it gets Green Guard Gold certified.
And about 30 minutes after we're done is when somebody can get back in. So there's no chemical reaction or off gassing happening. It's more just about the sealant particles being absent the space. So
great.
And one last question: I saw the duct sealant and the envelope sealant are slightly different. They're not the same. The duct sealant is designed to withstand much higher static pressure that it's going to see regularly, whereas the envelope is not going to see that kind of natural pressure. So
same in concept of the sealant ability automated, but different in the makeup and
the concept that the whole concept of we're essentially putting higher pressure inside the ductwork, and it's going to leak to the lower pressure outside, carries the sealant through the cracks and the gaps in the ductwork, seals them on the way through.
All right.
And I
Well,
want to thank all the 70 plus that are still hanging with us here a half
Yeah.
hour after time. So
I know, yeah. Some of them may have fallen asleep, but you know, forgot to log out. No, yeah. Thank you all for sticking around. Ross, Bill, you know, we've got millions of homes with air leakage. We got to get out there. We got to get to work. So appreciate you all and the work Aerial Seal is doing to make it happen. So take care, everyone. We'll see you in October. Be well. Thank you.
Thanks so much. Thanks for the opportunity.
Bye.
Be sure to check out all of our courses available online that you can watch anytime and anywhere to pick up your CEUs. Before you go, make sure to subscribe to us on YouTube to get weekly updates and stay up to date on green building science courses, webinars, and home tours. Thanks again.